Alright, good morning students. Like you all know that we are on the last exercise of special products, that is exercise 3C. So today we are going to continue with the one of the questions of this exercise so that we are able to complete it. So I'm going to continue with question number 7. You must be knowing that before this, whatever questions were there, most of the questions we have already attempted. So kindly see how to do question number 7. The given values are a plus b is equal to 10 and a minus b is equal to 6. So now what you need to focus in here is that we have been given the sum of two values and the difference of two values. Now in this there is one direct formula that can be used, and the formula goes like this. So we are going to use the formula a plus b whole square minus a minus b whole square is equal to 4ab. Now this is a formula that you can learn, and it is very easy to learn this. The square of the sum minus the square of the difference is equal to 4 times the product. Now here we are going to substitute the given values. So it is going to become 10 whole square minus 6 whole square is equal to 4ab. Now what has been asked in this question is to find the value of AB. So this was the question. So you can see in this equation only AB is unknown to us. So let us solve it further. This becomes 100 minus 36 is equal to 4AB. So in order to get the value of AB, we can get 4 to this side. 100 minus 36 is 64. 4 will come to this side, so it will come in the denominator. So it will be equal to AB. Therefore, the value of AB will be equal to, when you cancel it, 60, and that becomes our final answer. I hope you have understood it. Now after this, we are going to proceed further with question number 9. Because question number 8 and question number 9 are very similar, so I am going to attempt question number 9 for you all. The given values again. What is given to us is the value of 3p plus 1 upon 3p, which is given as 2 root 3. We have to find a number of different things in this question. The first thing they are asking is to find the value of 3p minus 1 upon 3p. So this is what we have to find. Now if you relate to it, what we have done in question number 7, the sum of the terms, the difference of the terms. So one formula that has both of them is what we have used in question number 7. So we are going to use the same formula in here. So using a plus b whole square minus a minus b whole square is equal to 4ab. Here a is actually given by 3p and b is given by 1 upon 3p. I hope you all can relate to it. So we are going to simply substitute these values in the given formula, and then we are going to get the answer. So what will it become? It will be 3p plus 1 by 3p whole square. Remember a plus b whole square minus 3p minus 1 by 3p whole square is equal to 4 times of 3p into 1 by 3p. I hope you all can relate to it. I have simply substituted the value of a and b in here. Now on the right side, if you see, they can be directly cancelled because 3p and 3p are same and they are in multiplication. One is in the numerator, one is in the denominator, so you can simply cancel it. The value of 3p plus 1 by 3p is given to us, so it will be 2 root 3 whole square. This is unknown, which we are going to find, so this will be 3p minus 1 upon 3p whole square, and on the right side we have 4. I hope this much is clear. So we are going to simplify it further to actually get the answer. When we are going to do the square of 2 root 3, the square of 2 is going to happen, that is 4, and the square of root 3 is going to happen, that is 3. I hope you all know that the square of a square root cancels it. So we have 4 into 3. The power has been distributed. It was 2 root 3, the square of 2 is 4, the square of root 3 is 3, and then they will be multiplied. Minus 3p minus 1 by 3p whole square is equal to 4. So let's take this bracket to the other side and bring 4 to this side. So it will be 12 minus 4 equal to 3p minus 1 by 3p whole square. So I hope you know, in order to get the value of this bracket, we have to take the square on the other side. When the square is taken to the other side, it becomes the square root. 12 minus 4 is 8. So let me swap the sides. So therefore, 3p minus 1 by 3p will be equal to plus minus square root of 8. Now why did I put plus minus? Now let us take a very simple example. When we are finding the square root of 4, you have to get a digit which when multiplied to itself should give us 4. That is how it goes. So you must be knowing, either we multiply plus 2 into plus 2, we will get 4, or we multiply minus 2 into minus 2, we are still going to get 4. So that's why whenever we are finding a square root of a given number, it can be either positive or negative. I believe you have understood it. Then in the next step, let's do the prime factorization of 8. This is how we find the square root. 2 into 2 is 4, into 2 is 8. Now one pair is formed, out of which the digit can be taken out. So we will have 2 outside, and what is left in the root? Root 2. So that becomes our final answer. So this was the first part of question number 9. Let's proceed with the second part of it now. In the second part, they want us to find the value of 9p square plus 1 by 9p square. This is what they want. Now in order to understand it, you need to know that the value of 3p plus 1 by 3p is given to us. And if you have seen it carefully, if I do the square of 3p, the square will be distributed, so it will be the square of 3 and the square of p. So that will give you 9p square, the required term. So because the value is given to us, I am going to use a direct formula, that is the square of the sum of two terms. A plus b whole square is equal to a square plus b square plus 2ab. Here you need to understand that a is equal to 3p and b is equal to 1 upon 3p. We are on the same question, right? So let's substitute the values. It will be 3p plus 1 by 3p whole square is equal to the square of the first term, that is 3p. I hope you are getting it. Why we are doing it? Because I want this term. Plus 1 by 3p whole square plus 2 times of 3p into 1 by 3p. I have simply substituted the values of a and b in here in the formula. So again, they are in multiplication, the brackets. So this will be cancelled. This value we already know, 2 root 3 whole square. This becomes 9p square plus 1 by 9p square because the power is distributed, and we have a plus 2 here. This we have already calculated in the previous part. This came equal to 12. I hope you can understand it. So 12 minus 2 is equal to, because plus 2 has been taken to this side, 9p square plus 1 by 9p square. Therefore, the required value 9p square plus 1 by 9p square will be equal to 12 minus 2, that is 10. So this becomes our final answer. I believe you have understood it. In case you all have any sort of doubt, we will have the Google Meet again. In the Google Meet, we all can discuss it. So there is one more part to this question. Let's complete that part also. In the third part, they want us to find 81p to the power of 4 plus 1 upon 81p to the power of 4. Again, you need to understand 81 is the square of 9 p to the power 4 is the square of p square. That means if I carry forward from the second part where I have found the value of 9p square plus 1 by 9p square, I can still get the value of this. Means I have to again go for the square of the previous part. What do I mean here is, I'm going to use the same formula. A plus b whole square is equal to a square plus b square plus 2ab. Here, this time, a is equal to 9p square. Remember the previous part, the second part that we have done. And b is equal to 1 upon 9p square. Can you relate to it? Why I am taking these terms? Because the square of 9 is going to give me 81 and the square of p square will give me p to the power 4. That is what is required. So let's substitute the formula. It will be 9p square plus 1 by 9p square whole square. I have simply substituted the value of a and b. Will be equal to the square of 9p square plus the square of 1 by 9p square plus 2 times of 9p square into 1 by 9p square. Again these terms will be cancelled. This value we have already found. It came equal to 10. So it will be 10 square is equal to 81p to the power 4 plus 1 upon 81p to the power 4 because the power has been distributed plus 2. Therefore, the value of 81p to the power 4 plus 1 upon 81p to the power 4, I have simply swapped the sides. So on this side it was 10 square, that is 100, plus 2 will be taken to that side, so it will be minus 2. So the answer will be 98. That becomes our final answer. So this was question number 9, and I have told you all the 3 parts of this particular question. I believe you have understood them. Now turn the page, come to question number 10. There the value given is the difference of the two terms. The procedure is going to remain the same. The way we have done question number 9, in the same way you have to do question number 10, question number 11 are both same, right? So I'm going to directly proceed further with question number 12. So let's see how question number 12 has to be done. Alright, question number 12. In question number 12, they have given r square plus 1 by r square is equal to 7. And we have to find in the first part the value of r plus 1 by r. So this is quite simple. We have r plus 1 by r. So if I proceed further with the formula of a plus b whole square, I will get all these terms. How? Let's see. Using a plus b whole square, which is equal to a square plus b square plus 2ab. Okay. Here a is equal to r, I believe you can see that, and b is equal to 1 upon r. So let us continue further. Let's substitute the values and see what happens next. So when we substitute values, the value will be r plus 1 by r whole square will be equal to r square plus 1 by r square plus 2 into r into 1 by r. This term will be cancelled. The value of r plus 1 by r we have to find. So we are going to keep the left hand side like this. The value of r square plus 1 by r square was given to us. So I'm going to put it as 7 plus 2. So this is going to be 9. So in order to find r plus 1 by r, like we have done earlier, we will take the square on the other side. So it will become plus minus square root of 9. That is equal to plus minus 3 into 3, that is how we factorize it. So the answer is plus minus 3. Because we have got a pair, 1 can be taken out. So this becomes our final answer, right? In the second part, we have to find the value of r minus 1 by r. So instead of using the formula of a plus b whole square, we are going to use the formula of a minus b whole square, right? Because the minus is there involved in this particular question. So a minus b whole square is given by a square plus b square minus 2ab. Again, here is r and b is 1 by r. Substituting the values, r minus 1 by r whole square will be given by r square plus 1 by r square minus 2 into r into 1 by r. R and r term are gone. So what do we have? We have to find this. So we'll keep it on the left side. This will be equal to the value of r square plus 1 by r square is 7 minus 2. So this turns out to be 5. Therefore, r minus 1 by r will be equal to plus minus under root 5. Now because we cannot proceed further, so this becomes our final answer. I hope this part is okay. Now after doing question number 12, if you see question number 13 is similar. So I am going to proceed further with the last question of this exercise, that is question number 14. Remember, whatever questions I am discussing right now will come in the fair register. And the rest of the questions, always you have to practice them in the practice copy or in some rough notebook. Okay. Now question number 14 is express each of the following trinomials as a perfect square. So let's do the third part of it. In the third part, so I'm doing question number 14, third part. Trinomial is given. Trinomial is an expression which contains 3 terms in it. I hope you all know this. So we have to convert the given trinomial in the form of a perfect square. So the expression given is 9x square plus 24xy plus 16y square. So this is the given expression. So first of all, in the trinomial, you have to select the terms which are actually perfect squares. That means the terms which can be written in the form of perfect square. Now what is a perfect square? Which has a square over it. Okay. So if you see here, this is having a square in here and 9 is also a square. So instead of writing it as 9x square, I am going to rewrite it as 3x whole square. Can you understand it? The square will be distributed. The square of 3 is 9. The square of x is x square. So we are getting the same term. I am going to select the second square term, that is this. So plus 16y square can be written as 4y whole square. Now I am not going to touch this. Now this is somehow taking the form of a square plus b square. So let's try doing it by writing 2ab, where 2 is written like this, a is 3x and b is 4y. Now if I see this term, if I simplify it, why did I do it? Because the form of a square plus b square plus 2ab was coming up. So I have written it. If I am able to do this, then it will become a plus b whole square. That will be a perfect square. That is what is asked in the question. Now the third term which I have got is because of the first 2 terms which I have somehow developed. So now see, we are going to cross check whether this term is the remaining term of the given expression or not. 2 into 3 is 6, 6 into 4 is 24. You are getting it. X into y is xy. That means you are getting exactly the formula of a square plus b square plus 2ab. So this can be written as a plus b whole square. So what is a in here? It is 3x. What is b in here? It is 4y. So it can be written as 3x plus 4y whole square, and that is a perfect square. I believe you have understood it. Let's do one more part of this particular question, that is the fourth part. In the fourth part, we have been given fractions, right? So the fourth part is 9x square upon 25 minus 3xy upon 5 plus y square upon 4. Again, in this trinomial, we are going to do the same thing if we can frame the perfect square. So the first term, if you see, if I write it as 3x upon 5 whole square, if I distribute it, am I getting the same term? Yes, because the square of 3 is 9, the square of x is x square, the square of 5 is 25. I'm going to bring the second square term here. So it is positive, so thus it can be written as y upon 2 whole square. Why? Because the square of y is y square, the square of 2 is 4. Now the third term, instead of seeing this, because now this is minus, somehow it is taking the form of a minus b whole square. So if I try to formulate it by using 2 minus 2, I mean the first term means the first bracket into the second bracket, and then I cross check it with this remaining term. What will happen? 2 and 2 will get cancelled. 3xy is left in the numerator, which we are getting, and 5 is left in the denominator. So it is clearly giving us the remaining term. So yes, this is actually 3x upon 5 minus y upon 2 whole square. Why minus? Because this is a form of a minus b whole square. So with this, we are done with the chapter named Special Products. I believe you were able to understand it. See to it that you keep your work completed. Do not keep your work pending. And we are going to continue with the next chapter, Factorization, in the next video or maybe in the Google Meet. Keep all your queries ready, and whenever we have the next class, you may ask it. Thank you so much, class. Take care of yourself.